Lesson: Data Preprocessing Techniques for Machine Learning Models. Data preprocessing is a pivotal stage in the workflow of machine learning, particularly within the context of AI-driven security analysis. Effective data preprocessing can significantly impact the performance of machine learning models, ensuring that the insights derived are both accurate and actionable. This lesson delves into the multifaceted techniques of data preprocessing, tailored for professionals aiming to excel in data management for cybersecurity analysis. The initial step in data preprocessing involves data cleaning, which addresses missing values, noise, and outliers. In cybersecurity datasets, missing values can arise due to incomplete logs or network failures. Techniques such as mean imputation, regression imputation, or more sophisticated methods like k-nearest neighbors imputation are commonly employed to handle missing data. For instance, in a dataset recording login attempts, missing timestamps can be filled using the mean of available timestamps to maintain analytical integrity. Additionally, outlier detection is crucial, as outliers can skew the results of security models. Tools like z-score analysis and the interquartile range method are effective in identifying anomalies that might indicate security breaches or data errors. Once the data is cleaned, transformation processes such as normalization and standardization are necessary to ensure that the data is in a suitable form for model training. Normalization scales the data to a range of 0 to 1, which is particularly beneficial for algorithms that compute distances between data points, such as KNN and k-means clustering. In cybersecurity, normalization can be applied to network traffic data to ensure that the features like packet size and duration are uniformly scaled. Standardization, on the other hand, transforms the data to have a mean of 0 and a standard deviation of 1, which is essential for models like support vector machines that assume normally distributed input data. Practical tools like Python's scikit-learn library offer functions such as min-max scaler and standard scaler that streamline these processes, allowing cybersecurity professionals to efficiently prepare data for analysis. Feature selection and extraction are subsequent steps that refine the dataset by reducing dimensionality and enhancing the model's performance. In cybersecurity analysis, the vast array of features such as IP addresses, port numbers, protocols, etc., can lead to the curse of dimensionality, where the model becomes overfit and less generalizable. Feature selection techniques, including recursive feature elimination and random forest importance, can identify the most relevant features that contribute to the prediction accuracy of security threats. Moreover, feature extraction methods like principal component analysis can be employed to create new features that capture the essence of the original data while reducing noise. Implementing PCA on a dataset of network traffic can help in visualizing the underlying patterns of normal and suspicious activity, thereby aiding in threat detection. Data integration and reduction are also critical components of preprocessing, especially when dealing with heterogeneous data sources common in cybersecurity settings. Data integration involves merging data from different sources, such as firewall logs, intrusion detection systems, and endpoint security tools, into a cohesive dataset. This process may require resolving schema conflicts and ensuring data consistency. Techniques such as data warehousing and the use of extract, transform, load tools like Apache NiFi can facilitate this integration. Data reduction, on the other hand, focuses on reducing the volume of data while preserving its analytical value. Methods such as data compression, aggregation, and sampling are employed to manage large-scale datasets efficiently, ensuring that real-time analysis remains feasible without compromising on detail. Another essential aspect of data preprocessing is data discretization and encoding, which is crucial for transforming categorical data into a numerical format that machine learning models can interpret. In the realm of cybersecurity, certain attributes like user roles or action types are categorical. Techniques such as one-hot encoding or label encoding convert these categories into a binary or ordinal format, respectively. For example, a categorical feature indicating user access levels, such as admin, user, guest, can be encoded to numerical values that models can process effectively. The Pandas library in Python provides robust functions for encoding categorical variables, streamlining this segment of preprocessing. Furthermore, handling imbalanced data is a prevalent challenge in cybersecurity datasets where the occurrence of attacks is often significantly lower than normal activity. Imbalanced datasets can lead to biased models that favor the majority class, thus undermining the detection of security threats. Techniques such as resampling, which includes oversampling the minority class or undersampling the majority class, can counteract this imbalance. Advanced methods like synthetic minority oversampling technique create synthetic examples for the minority class to bolster model training. These approaches are crucial in ensuring that the model remains sensitive to security threats, despite their infrequency. Incorporating these pre-processing techniques into cybersecurity workflows can be demonstrated through real-world case studies. For instance, a study on intrusion detection systems showed that applying normalization and PCA improved the detection rate of attacks by 15%. Another case study on fraud detection in financial transactions highlighted the effectiveness of SMOTE in increasing the true positive rate by 20% without affecting the false positive rate. In conclusion, data preprocessing is a critical phase in the development of machine learning models for AI-driven security analysis. By implementing a systematic approach to data cleaning, transformation, feature selection, integration, and handling of imbalanced data, cybersecurity professionals can enhance the reliability and effectiveness of their analytical models. Tools and frameworks like scikit-learn, Pandas, and Apache NiFi provide robust support for these processes, enabling professionals to tackle real-world challenges with proficiency. As the landscape of cybersecurity continues to evolve, mastering these pre-processing techniques will be indispensable for leveraging AI's full potential in safeguarding digital assets.